Hi everyone. In this video, we're going to use similar triangles to set up a proportion and solve indirect measurement problems. So remember, with similar triangles, you can make a proportion to find missing measurements. If a picture is not given, start by drawing and labeling a picture of the situation. And you're always going to have similar triangles when you solve these problems. Okay, so how high is a tree that casts a 26-foot shadow? At the same time, a 4-foot pole casts a shadow that is 3 feet long. So I have to start by drawing a picture so I can see what's going on. We have our sun. We have a tree and the shadow for the tree. And you can envision the rays of the sun making a triangle with the tip of the tree to the tip of its shadow. And we know the length of that shadow, they told us, was 26 feet. At the same time, we have a 4-foot pole. And the length of the shadow from the 4-foot pole is 3 feet. You can tell my sketch is definitely not to scale. It's just a quick sketch. But what we get is we get a set of similar triangles. And our job is to find the height of the tree, which I'm going to call x. So I can set up my ratios. You can set up ratios within the similar shape or between the similar shape. It doesn't matter as long as you're consistent. So when I like to do these problems, I like to set up the height compared to the shadow in the first triangle is equal to the height compared to the shadow in the second triangle. Now to solve that proportion, I'm going to do cross products. So I do 3 times x equals 26 times 4. So I get 3x equals, I'm multiplying 26 by 4, that's 104. Then I would divide by 3. So I get x equals, I'm going to use my fraction key. So I get my exact answer. So I'm doing 104, fraction key 3. I'm getting 34 and 2/3, and my label would be feet. Looking at my next example. A triangle is formed by the building's height and shadow. Another triangle is formed by the flagpole's height and its shadow. Find the height of the building. So they have the pictures already set up and labeled for me, so I can go ahead and set up my ratios. So again, I like to do height compared to shadow, so it would be x over 20 equals 20 over 4. Okay, and again, you can solve this with cross products or scale factors. In this case, I'm going to do a scale factor going from the bottom to the top. So to go from 4 to 20, I would multiply by 5. So doing that in my first ratio, multiply by 5, I get x equals 20 times 5, which would be 100 feet. This next example says, use similar triangles and a proportion to find the length of the lake shown. When you look at this picture, you have to look at it carefully. This is called a pair of nested triangles, which means one triangle inside the other. So if you look at it, let me use the highlighter here. Let me change my pen tool. I don't know if it's going to let me change. All right, there we go. All right, so if we look at the highlighter tool, we have this little triangle that I just outlined in blue, and that's inside of this big outside triangle that I just outlined in green. So these two triangles are actually similar triangles. So we can set up our proportion. Our job is to find the length of the lake, which is the n. That's on the big triangle. So the outside big triangle, the bottom edge of it is 118. So my ratio would be n over 188 equals, now looking at the corresponding ratio for the smaller triangle, it would be 42 compared to 84. Okay, and then again, you can solve this either with cross products or scale factors. When I go to solve this one, I'm noticing to get from 84 to 42, I multiply by a half. So doing that same thing in my first ratio, to get my value of n, I would do 188 times a half, which gives me 94 meters. I hope this video helps. Please let me know if you have any questions. Thank you.